Hello everyone. Today I will talk through this provided notebook on Avalon age prediction. This notebook demonstrates how machine learning can be used to estimate Avalon age for physical measurement. Traditionally, age is determined by cutting shells and counting rings, which is expensive and consuming. This project shows how automated prediction can be improved efficiency and sustainability. And here's the business problem part. In this section, the notebook explained the business context, manual age estimation limits, scalability, and increased labor costs. It also makes sustainable halving more difficult. The executive summary highlight goals such as reducing cost, improving accuracy, and supporting responsible resource management. The challenge section shows that adoption, cost, and regulation must be considered in real-world development. And here we come to the library. This notebook installed and imports several libraries. This include Pandas, NumPy, and something else. These tools support data manipulation, visualization, and machine learning modeling. And here we'll come to the data description and source. It comes from the UCI machine learning repository. It contains 8 input features, including sex, length, diameter 8, and weight measurement. The target variable is rings, which represents age, adding 1.5 gives an approximate age in years. And here's the importing and preview data. The notebook imports the dataset using the UCI interface. The datasets contain 4,177 observation and 8 features. The preview shows the mix of categorical and numerical variables. The target variable is stored separately. And here we explore the dataset. The EDA section, the notebook examine the data quality. It confirms that there are no missing value and no duplicate records. The info output shows that most features are numerical while sex is categorical. This indicates that the minimal clean is required. Next, descriptive statistics are computed. The summary shows the mean. Here. Summary shows the mean standard deviation and range for each variable. The skewness analysis indicate that some features such as height and weight are positively skewed. The target variable range also shows right skewness. The box plot is used to visualize the outlier. The notebook applied Turkey rules to identify extreme values. Now come to the feature importance. In this section, the notebook prepared the data for modeling. The categorical variable sex is encoded numerically. The feature and target are separated into X and Y. This prepared the dataset to supervise learning. And the dataset is then divided into training and testing model. Mm, using 80 and 20 split. This creates a holdout sample for unbiased evaluation. Standardization is applied using standard scale. Both feature and target are transformed. This helps model converge faster and improve numerical accessibility. And here's the feature importance. The notebook compute feature importance using random forest. This helps identify which variable contribute most to prediction. The bar chart shows the shell weight is most important feature. Shock weight and visceral weight are also influential. Sex are relatively low importance. This suggests that physical mass is more informative than gender. And the baseline base learner regression section. The notebook then evaluates several regression model. These include multiple linear regression like Lasso-Ridge. Each model is trained on standardized data. Performance is measured using mean square error, mean absolute error, and R-square. Scatter plot compare actual value with predicted value. For example, the multiple linear regression achieves in R squared about 0.53. This indicates the moderate explanatory power, and Lasso regression the Lasso regression perform worse with an R squared close to 0.14. This suggests that excessive regulation removes important features. Other models balance bias and variance differently. These results illustrate the bias-variance trade-off. Linear model having higher bias but lower variance. Decision tree and neural network have lower bias but higher variance. Random forest balance both by averaging multiple trees. This explains why it performs well in feature importance analysis. And the holdouts. Um, this result, the notebook used holdout test set for validation. This ensure that performance reflects generalization ability. The use of standardized evaluation metric improves reliability. And these result having importance practical value. Automatic age estimation reduces labor costs. It supports sustainable happiness. It also improves decision making for fisher and regulators. However, here is the limitations. The dataset does not include environment variables. Some features are highly correlated. More advanced hyperparametric tuning could improve accuracy. In conclusion, this notebook demonstrates a complete supervised learning workflow. It converts data exploration, preprocessing, modeling, and evaluation. Random forest and ensemble approaches show strong performance. This project highlighting how machine learning can support sustainable agriculture. And that's all. Thanks for listening.